What's going on, my friends? Welcome back. Hope you guys are ready to jump into another Kurzgesagt video. An exciting one today. We're going to watch wormhole stuff. So, I'm not here to educate you guys. I'm just trying to, make science a little bit cooler, pique people's interests. And I don't want to just sit around talking about this stuff all the time. I want to actually create some things. So that's why I'm doing these two things. I'm creating a post-quantum VPN that'll protect you from quantum computers. The alpha is about to come out very soon. So if you want to get the free alpha, go sign up in the description to be notified when it comes. And then I'm also doing this daily dance newsletter thing. There's lots of science going on around the world. It's really hard to keep up with just how quickly we're advancing all these different areas. So this newsletter just breaks it down in a really quick format, a couple minutes to read. The crazy humans are always coming up with crazy new experiments and ideas, and there's all these crazy results coming out every single day. And it can feel really overwhelming to keep up with. It's not like when you go into a science news site where there's just so much going on and then you haven't got any tech news, you haven't got anything else. This squishes it all, compresses it all down to really easy just to skim through, see what's happening, and how quickly we're progressing. If you're a curiosity-driven being like I am, it's a pretty awesome thing. And it's completely free, and I try to make them personal and fun and put all kinds of other stuff in there, so you should come get involved. Alrighty, Wormholes Explained, breaking space-time.
If you saw a wormhole in reality, it would appear round, spherical, a bit like a black hole. Light from the other side passes through and gives you a window to a faraway place. Once crossed, the other side comes fully into view, with your old home now receding into that shimmering spherical window.
What a cool visual that was.
But are wormholes real, or are they just magic disguised as physics and maths? If they are real...
Well, physics is magic, my friends. You heard that quote, Arthur C. Clarke, any sufficiently advanced technology is indistinguishable with magic. And ain't it true?
How do they work, and where can we find them? For most of human history, we thought space was pretty simple. A big, flat stage where the events of the universe unfold. Even if you take down the set of planets and stars, there's still something left. That empty stage is space, and it exists, unchanging and eternal. Einstein's theory of relativity changed that. It says that space and time make up that stage together, and they aren't the same everywhere. The things on the stage can affect the stage itself, stretching and warping it. If the old stage was like unmoving hardwood, Einstein's stage is more like a waterbed. This kind of elastic space can be bent and maybe even torn and patched together, which could make wormholes possible. Let's see what that would look like in 2D. Our universe is like a big flat sheet. Bent in just the right way, wormholes could connect two very distant spots with a short bridge that you could cross almost instantaneously, enabling you to travel the universe even faster than the speed of light.
One really crazy thing about these wormholes that if you have one of these things, we don't know if they exist, but imagine you have one, right? And you're able to manipulate the openings. So you imagine one opening near the edge of a black hole, right? Where time passes slower. The rate of time is slowed at the edge of that black hole. Then you can transform this wormhole from being a tunnel from one place to another in the universe to being a shortcut from one moment in time to another moment in time. It's, in principle, a time machine. So isn't that incredible? Hypothetical ideas. So we don't know if they're real. They come out of the equations. We've never seen a wormhole. If we had one, we don't know if we'd be able to go through it. But the math kind of gives this to us as a real possibility.
So, where can we find a wormhole?
In the ground, obviously,
on paper,
where worms are.
General relativity says they might be possible, but that doesn't mean they have to exist. General relativity is a mathematical theory. It's a set of equations that have many possible answers, but not all maths describes reality. But they are theoretically possible, and there are different kinds. The first kind of wormholes to be theorized were Einstein Rosenbridges. They describe every black hole as a sort of portal to an infinite parallel universe. Let's try to picture them in 2D again. Empty space-time is flat, but curved by objects on it. If we compress that object, space-time gets more curved around it. Eventually, space-time becomes so...
Just remember, you're imagining space-time here as like a flat sheet of fabric, which just isn't what it is, and it's not a good analogy, but you know what? We physicists love to lie to you people, and anyway.
Warped that it has no choice but to collapse into a black hole.
No, what it is where the curvature, that flat sheet that he showed you, it basically curves down an infinite amount, because according to Einstein's general relativity, his equations blow up at, past the event horizon where that singularity is, and they go to infinity. The density, all sorts of wacky things, the volume, and so that curvature goes to infinity, and so it also has infinite gravity, infinite mass. So it's these things probably don't even exist. Like when you come across infinities in physics, in nature, it's kind of a sign of our equations are probably fairly limited, and we need a better theory. So I could talk about this all day, but maybe we should continue. So just think of it like that. So where the curvature goes to infinity, it's like another universe in there because it's infinitely curved. See?
A one-way barrier forms.
You might ask, what the hell is it curving into? Like, where is that place? We'll talk about this later on in the video because it's kind of interesting. It has to do with like higher dimensional stuff.
Event horizon, which anything can enter, but nothing can escape. Trapped forever at the singularity at
Unless you dark energy.
its core. But maybe there is no singularity here. One possibility is that the other side of the event horizon looks a bit like our universe again, but mirrored upside down, where time runs backwards. In our universe, fall into the black hole. In the parallel universe with backwards time, the mirror black hole is spewing things out a bit like a Big Bang. This is called a white hole. The Einstein Rosenbridges can't actually be crossed. It takes an infinite amount of time to cross over to the opposite universe, and they crimp shut in the middle. If you go into a black hole, you won't become the stuff coming out of the white hole.
So this is a problem with all the stuff he's talking about here, because this is all, again, completely theoretical. So to say you can't do that would be, naive. We don't know what we don't know. And some of the math, there is math that shows you can. So I do have a problem here, but this is super speculative stuff, essentially, right? Just remember, we're doing this because it's fun. Okay?
Out of
So
the
don't
white
get
hole,
too upset with
you'll
me.
only become dead. So, to travel the cosmos in the blink of an eye, humans need a different kind of wormhole, a traversable wormhole.
Very old string theory wormholes.
If
Okay.
string theory or
You might have heard how a wormhole in Einstein Rosenbridge might actually be equivalent to a pair of entangled black holes. If you want to hear more about that, we won't talk about that in this video. Go check out Leonard Susskind's work. I'm sure he has some YouTube videos. Yeah.
one of its variations is the correct description of our universe, then we could be lucky and our universe might even have a tangled
That's
web of
awesome.
countless wormholes already. Shortly after the Big Bang, quantum fluctuations in the universe at the smallest scales...
If string theory is correct, black holes aren't really black holes. They're these things called fuzzballs. Or at least there might be also these things called fuzzballs, where it's very different, okay? We'll talk about this soon.
far, far smaller than an atom, may have created many, many traversable wormholes. Threaded through them are strings, called cosmic strings. In the first billionth of a trillionth of a second after the Big Bang, the ends of these tiny, tiny wormholes were pulled light years apart, scattering them through the universe. If wormholes were made in the early universe, whether with cosmic strings or some other way, they could be all over, just waiting to be discovered.
I love this synthwave sound going on in the background. It fits,
One might even
surprisingly.
be closer than we realize. From the outside, black holes and wormholes can look very similar, leading some physicists to suggest the supermassive black holes in the center of galaxies are actually wormholes. It will be very hard to go all the way to the center of the Milky Way to find out though, but that's okay. There might be an equally extremely hard way to get our hands on a wormhole. We could try to make one.
What a visual. Man, mate.
To be traversable and useful, there are a few properties we want a wormhole to have.
I gotta tell you guys about these things called orcs. They could be the most mysterious thing in astrophysics, at least in recent years. these odd radio circles, which could be wormholes. A couple of Russian physicists proposed that these things might actually be wormholes. They're really weird things. We have no explanation for them just yet, and they're huge, like much bigger than galaxies.
First, it must obviously connect two distant parts of space-time, like your bedroom and the bathroom, or Earth and Jupiter. Second, it should not contain any event horizons which would block two-way travel.
That could be a
Third,
problem.
it should be sufficiently sized so that the gravitational forces don't kill human travelers. The biggest problem we have to solve is keeping our wormholes open. No matter how we make wormholes, gravity tries to close them.
Gravity.
Gravity wants to pinch it closed and cut the bridge, leaving only black holes at the ends. Whether it's a traversable wormhole with both ends in ours, or a wormhole to another universe, it will try to close unless we have something propping it open. For very old string theory wormholes, that's the cosmic strings job. For man-made wormholes, we need a new ingredient: exotic matter. This isn't anything like we find on Earth, or even antimatter. It's something
Let's just invent something that doesn't exist for the sake of argument. That's what we're
totally
doing
new
here.
and different and exciting.
You might be like, you got a point, but we did that a lot in math. Have you ever heard of imaginary numbers?
With
Complex
crazy
numbers.
properties like nothing that's ever been seen before. Exotic matter is stuff that has negative mass. Positive mass, like people and planets and everything else in the universe, is attractive because of gravity. But negative mass would be repulsive. It would push you away. This makes a kind of anti-gravity that props open our wormholes.
Lots of famous physicists in the late 1980s began to ask the question, would it be possible to prevent wormholes from shrinking and collapsing by putting some sort of matter or fields inside them, right? And we basically found out, unsurprisingly, that the only way to hold a wormhole open is to put something inside the wormhole which repels gravitationally, right? So it pushes the walls of the wormhole apart and holding it open. And to repel gravitationally, it has to be something made from negative energy. And the intriguing thing is we know how to make matter that has negative energy and correspondingly negative mass, because Einstein tells us that mass and energy are equivalent. So we know how to make tiny, tiny amounts of this stuff thanks to the laws of quantum physics. And this is done. We can do this in the laboratory. And so then the question became, is it possible that laws of nature, do they allow you to make and collect together enough negative mass, negative energy inside a wormhole to hold it open? That has essentially been a major area of theoretical research for a long time, but we don't have the technology to do this experimentally. But a major area of theoretical research, basically asking what all the laws of physics say about them, right? The key thing is that quantum physics is the set of laws that govern whether or not, basically, if you can have material of some sort that has negative mass or negative energy. And these laws of quantum physics seem to be saying that it's impossible to collect enough negative mass and negative energy to basically hold a wormhole open. But, we don't know that for sure. So that's sort of the story of where wormholes stand. The question of how they influence time really depends on the properties of the wormholes, right? Which depends on the details of the negative mass you put in there to hold the wormhole open. So we know that if you're going to be able to travel through the wormhole, then it may be able to slow time a lot. But unlike a black hole, it can't have a horizon where time is flowing downwards when you reach the horizon, because you'd never be able to travel back up through that horizon. Wormhole, by definition, is something that you should be able to travel back and forth through in either direction, right? How much influence it has on time really depends on details, which depends on how it was built and how much negative energy or negative mass you have when you build it. And so we don't have a clear, distinct answer in that case.
And exotic matter must exert enormous pressure to push space-time open, greater even than the pressure at the centers of neutron stars. With exotic matter, we could weave space-time however we see fit. We may even have a candidate for this exotic matter, the vacuum of space itself. Quantum fluctuations in empty space are constantly creating pairs of particles and antiparticles, only for them to be annihilated an instant later. The
Virtual particles that don't actually exist. Just remember that. Something else going on. He's not being very honest.
vacuum of space is boiling with them, and we can already manipulate them to produce an effect similar to the negative mass we're looking for. We could use this to stabilize
We talk about this in the very last video, so come check it out if you want to hear more about dark energy and what he's talking about right now.
Wormholes. Once we're keeping it open, the ends would start together, so we'd have to move them around to interesting places. We could start by wiring the solar system, leaving one end of each wormhole in orbit around the Earth. We could fling others into deep space. The Earth could be a wormhole hub for a vast interstellar human civilization spread over light years, but only a wormhole away. However, wormholes have
so many references. Have you noticed the wormholes are always around like Saturn and Jupiter? That is totally some sci-fi throwbacks and references to things like 2001, where that's where they had their like monoliths and Stargate, that bit where he goes psychedelic experience, and also Interstellar. But you know, Interstellar was famously Christopher Nolan's like ode to 2001, which is his favorite film. I remember him saying, "Yeah, awesome
dark
stuff."
side.
Back to the
Even
future. You know what? We haven't talked about time travel in a while, so maybe we should do a video soon.
Breaks the universe in fundamental ways, potentially creating time travel paradoxes and violating the causal structure of the universe. Many scientists think that this not only means they should be impossible to make, but that it's impossible for them to exist at all. So for now, we only know that wormholes exist in our hearts and on paper in the form of equations. We know you want to know more about universe stuff, so we're trying something new.
Don't want to make the video too long, so if you want to hear more about wormholes and all the higher dimensional stuff, you'll find it in a lot of my other videos, but especially this Interstellar video where we explain the ending and how it involved higher dimensional stuff in wormholes, so you should definitely go check that out. And yeah, I'll catch you guys next time.